Hello and welcome. This video covers SLOs 18 and 19. The goals of this video are to be able to graph polar coordinates on a polar plane and to determine multiple representations of a point in the polar plane, including those with positive and negative values of r. Let's take a look at a polar plane. This is very different from our Cartesian coordinate plane because of the angles. We have angles here, and we also still have x and y axes, and you will be using these to show distance, so 1, 2, 3, 4 all over the graph, but you're also now dealing with angles, and we're going to get into how to graph it in just a second. Let's talk about polar coordinates. So polar coordinates are written in the form r theta. This is different from a Cartesian coordinate plane, which has rectangular coordinates in the form x and y. The pole is the origin of the coordinate plane, and the angle theta is measured in radians based on the direction of r. So let's begin graphing and just understanding how this works. So we're asked to plot the point 2 pi over 3. Well, this graph has the x and y axes scaled by 1, so we'll now move out 2 spots and then turn to the angle pi over 3. That's simple. Let's get into a different angle. We have 4, 5 pi over 6. So we're going to go over 1, 2, 3, 4, and turn to get here to 5 pi over 6. However, there is another way to write this angle, and we can do this by using a negative value for r. Another way to write this is negative 4 11 pi over 6. Here is y. Let's say we were to graph 4 11 pi over 6. We would be over here, and we would go out 1, 2, 3, 4 spots. Saying it's a negative 4, though, puts us across the polar plane and over here at 5 pi over 6. Now, let's plot the point negative 1 pi over 6. Well, we can go over here to pi over 6 and go out 1. However, we know this is negative 1, so we actually have to go across the other way 1 spot. This puts us here. So this means another way to write it is actually 7 pi over 6, because we've gone out 1 and moved by the angle 7 pi over 6. Let's now graph the point negative 3 5 pi over 3. Well, we can first think of this as 3 5 pi over 3, and then we'll deal with the negative in a second. So we'll go out 1, 2, 3 units and go across the polar plane to the angle 5 pi over 3. However, this is not 3 5 pi over 3. This is negative 3 5 pi over 3. So we have to go to the origin and see, again, 5 pi over 3 is across from the angle 2 pi over 3. That's why we're going this way. And we'll go 1, 2, 3 units back, and this will leave us right here. What's another way to write this? Well, we could write this with a positive r value, and we'll consider that it's 1, 2, 3 units out and has an angle of 2 pi over 3. Let's take a look at one final example. We're going to be plotting 2 points. So we have the points negative 4 pi over 2 and 3 2 pi over 3. So this again has a negative in front of the r value, so we're just going to consider it as 4 pi over 2 first. Let's go out 1, 2, 3, 4 units and rotate to a pi over 2 angle. Again, this has a negative r value, so we have to consider that. So we're going to go across the polar plane and go down 1, 2, 3, 4, and this gives us a point right here. And then we know another way to write this is 4 3 pi over 2, because this is 1, 2, 3, 4 units out, and has an angle of 3 pi over 2. Let's look at our next point. This is 3 2 pi over 3. So we'll go at 1, 2, 3 spots and go 1 over here to 2 pi over 3 for our angle. Now, this has a positive r value, meaning that we now can write it in a different way using a negative r value. So if we go across our polar plane, we can actually graph it with a negative r value. So I'll still have to go out 3 units, and we'll be going across from the angle of 2 pi over 3 to 5 pi over 3. So we can also write this as the negative 3 5 pi over 3. Now, in case that's unclear, let's think about it again. Let's say we graph this as 3 5 pi over 3, that would put us here, but the negative would take us back here. That's all for this video. I hope you have a good day. Thank you for watching.